Hello everyone, welcome to BHARGAV SUBS. I am fine. How are you? I hope you are very fine. So, in this class, let us discuss the concept regarding method of images. Okay, where we use this method of images, right? So, this method of images, image, while you are seeing the mirror, the reflection of you, okay, which was formed on opposite side, that is known as image. Okay, you can draw by extending the incident rays or from the incident image, okay, from the object, right? Similarly, in electrodynamics or electrostatics, we use a trick. Okay, it is a trick to solve problems. Okay, this is known as method of images. Okay, then you can ask, why you have uniqueness theorem? No, to solve the problem there is a uniqueness theorem 1 and uniqueness theorem 2. For finding V, you have uniqueness theorem 1. For finding E, you have uniqueness theorem 2. Then why there is a need of method of images? Yeah, if you don't know the uniqueness theorem, it is just shortcut. Okay, like uniqueness theorem, you have to find the solution, right? But without, you have to find the solution of Laplace or Poisson's, but without finding the solution, it is a shortcut. It is a trick to solve the problems. You will draw the just image and you can follow the procedure to find the potential or electric field. Yeah, this is a known as method of images. This concept name is known as method of images, right? In this, I will tell some examples and I will tell what is method of images, what is the exact definition and what is the procedure steps. Okay, while you are drawing a image, while you are drawing for a image for a charge. Okay, if you have a grounded plate, conducting plate, if there is a charge, then you have to find the potential at point P due to the charge. Okay, on the conducting field there is a charge, so there is a point charge on the above the conducting plate, it is grounded, so potential V is equal to 0 on the grounded plate, conducting plate. Above there is a point charge plus Q. Now you have to find the potential at point P, which has coordinates x, y, z. Okay, on the coordinate axis there is a point x, y, z. You have to find the potential at that point x, y, z. Now here you have the point above the conducting plane, okay, which is at a distance d. The point charge is at a distance 0, 0, d for suppose. So now you have to find the potential at d. Or you have a sphere and have a point charge at a certain distance a from center. Okay, from center you have a point charge at certain distance. Now you have to find the potential at point P in between this. Okay, there is a point charge at certain distance. Now here center O, there is a distance a and there is a point P in the between this, center and that point charge. Now you have to find the potential at this point charge due to that, at this point due to that point charge. Okay, you have uniqueness theorem, correct, but without knowing the total procedure, this is a trick, this is a shortcut. So now let us go into this concept and let us understand how this method of images is used in the field of electrodynamics to find the potential and electric fields. Okay, without going late, let us define the what is method of image. Now let us discuss what is the exact definition of method of images, right? I will write the method of images definition. I will explain some basic examples where we can apply this method of images and what is the trick. Okay, what is the trick you can use? For example, see, what is method of images? What is method of image? Method of image. So what you can say, I already told you, it is a trick. Okay, it is just some trick to solve some special type of problems in electrostatics, right? And also it also uses to solve the problems which involves uniqueness theorem, right? So this method of image is a trick. Okay, is a trick to solve some specific problems, right? Some specific problems in what? Electrostatics. In electrostatics or and the problems which involve uniqueness theorem, which involves uniqueness theorem, right? Which involves uniqueness theorem. So even though even though it involves uniqueness theorem, there is no need to apply the uniqueness theorem there. Okay, you directly solve the problem by applying method of images, the trick. Okay, so what I told, like, okay, uniqueness theorem and also some specific problems in electrostatics. Okay, so where you can use uniqueness theorem to solve the solution for Laplace equation. Correct, one solution will be there, Laplace equation. That solution you have to, like, you can find by using Laplace equation and all. Without using Laplace equation, Poisson's equation, you can able to find the potential at a point due to a point charge by applying the method of images. Okay, so without applying solution of Laplace equations, we can able to find potential by applying this trick. Correct? Yeah. Okay. Yeah. For example, see. In this method of images, you will assume a conducting plane. Okay, you will assume a conducting plane. So and conducting, you can assume conducting plane due to that point charge where it is present at a certain distance. There is an induction of, like, there is a induced charges on this plane, right? The negative charges, or if it is a positive, there is a negative charges. If it is negative, there is a positive charges induced, right? So there is a induced charges. So sorry, like, before induced charges, we are assuming no conducting plane. Okay, we are taking a conducting plane surface. Okay, we are considering a conducting plane surface from given charge at a certain distance, correct, at a certain distance. You are assuming, like, you are assuming the charge, you are assuming the plane, and you are grounding that plane. Okay, conducting plane, you are making the potential is equal to 0. Okay, so we are grounding the conducting plane so that potential on conducting plane is 0. Potential on conducting plane is 0. That is V is equal to 0. Okay, on the conducting plane, you are assuming that you are making that grounded, so that you can apply on both side. This potential is 0 now. So if you add this, like, on both sides the potentials, you will get 0. Okay, like, I will apply now. Wait. Okay, yeah. And so yeah, potential of potential at point P is not only, like, the potential at point P where the potential is getting is not only due to the charge, but also the induced charge which is present on the conducting surface. Okay, the potential at point P is not only due to the point charge, but also the charge induced on the conducting surface. Okay, conducting surface, like, it is also taking a contribution to give the potential to the point P. Okay, this where the charge is present on the conducting surface, it is also taking a contribution to give the potential at point P, right? Not only the charge. Okay, if you consider only the charge, then your answer will be wrong. Okay, Like for example, I will give you example. Okay, note down these points, like these are very important. Like in the, like this is the definition and some important points regarding the method of images, right? I will give one example. See, for example, if you take a conducting plane, okay, if you take a conducting plane, and there is a point charge present at a certain distance d, okay, if you take here, for example, this is the point charge q, correct? Now you are taking a conducting surface. This is grounded. Grounded means what? Here potential V is equal to 0. Okay, potential V is equal to 0. For example, it is at a certain distance d. Okay, so if it is at a distance d, then what is the coordinate of plus q? 0, 0, d. Correct? 0, 0, d, because z coordinate is d, x and y are 0. Okay, 0, 0, d. Now you have to find the potential at point P. So generally you can take it as like the distance between this is, for example, r. Okay, so simply you write potential V is equal to 1 by 4 pi epsilon naught q by r. You will apply this formula, but it was wrong. Okay, if you apply this formula, this was wrong, because I already told you there is a charge induced due to this point charge on this conducting plane. This is a conducting surface. Okay, conducting surface. So on this conducting surface there is a charge induced. Due to this plus q. So if the potential at P can be determined with the two values, plus q with this one, and also it involves these induced charges which was present on the conducting surface. Okay, due to this also there is a effect of potential on P. Okay, if you take only 1 by 4 pi epsilon q by r, which is a distance between these two, is completely wrong. Okay, you have to consider this also. Or for example, see, this is conducting surface. This is a sphere, this is a plane, rho L, rho, for example. So how you can draw image for this. Okay, this is the given plane, so you can draw here like this. It is the image for this and it is the image for this rho. So here V is equal to 0. Correct? You will draw the image for this, and you can apply the potential due to plus q and minus q is equal to 0. Okay, potential due to plus potential due to minus is equal to 0. Okay, you are applying here equipotential surface. This is known as equipotential surface. Okay, and for example, if you have a sphere, okay, for example, see, if you have a sphere, right, if you have a sphere of plus q charge at a certain distance, for example, this is a sphere, correct? This is a center, and here there is a plus q charge, and for example, combine these two. Okay, combine these two. Here if you take minus q, okay, if you want to find here due to plus q, if you take the potential due to only plus q, then it will be wrong. You have to apply the method of images concept, right, by taking a opposite charge in the sphere. Okay, for example, this is the radius of the sphere. 0 to plus q if the distance was a. Okay, and here to here if the distance was b, or here to here this distance was b. Okay, now here there is a point P. You have to find the potential at point P. How you can find? Now potential due to plus q and potential due to minus q is equal to 0. Okay, potential due to plus q plus potential due to minus q is equal to 0. What is the potential due to plus q? 1 by 4 pi epsilon naught q by distance. Okay, distance from the point P. Okay, distance from the point P. What is the distance from point P? A minus r. Correct? This distance is the distance between point P and plus Q. Okay, this is the total distance. This is the radius r. So this distance was total distance a minus r. A minus r. So 1 by 4 pi epsilon naught is 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught q by plus q by distance. Distance is a minus r plus potential due to minus q by 4 pi epsilon naught. Now at what distance the minus q with the p? This distance. How to find this distance? R minus b. Okay, complete radius minus b. R minus b. Okay, is equal to 0. Correct. So yeah, this is q dash. For example, this is two charges now, plus q minus q. So q dash. Okay, so you have to find this q dash or q also. Like, see, now what you have to do, like, you can transfer this to right hand side. So q by 4 pi epsilon naught a minus r is equal to q dash by 4 pi epsilon naught r minus b. Correct. 4 pi epsilon naught get cancelled. Q by a minus r is equal to q dash by r minus b. Here which was large? A is very large compared to b. Okay, a is very large compared to b. Then what you can take? Okay, so here yeah, you can take the two conditions. A is very greater, like comparison between a and r and b. So a is very large compared to r and r is very large compared to b. So you can apply this as, in the place of a minus r you can take a, because a was very large compared to r. So q by a is equal to q dash by r minus b. No, r is very greater, so r. Okay, so q dash is equal to how much? R by a into q. Okay, q dash is equal to r by a into q. Clear? Q by a is equal, q dash is equal to r by a into q. Okay, you can find like this. You can apply like this is the equipotential surface now, so you can apply both charges due to plus and minus q dash, like both charges is equal to 0. So you can apply the normal potential formula 1 by 4 pi epsilon naught q by distance. So a minus r is the here distance, here r minus b. So here a was very large compared to r, but comparing r and b, r was very large compared to b. Okay, same. So I remove, like, a minus r can be written as a. Okay, so a minus r can be written as a and r minus b can be written as what? R. So I substituted. So I got new charge q dash. Okay, so to finding this q, okay, q dash, you can apply this method of images, and also for finding potentials. Okay, and also we will do one problem on this, like method of images. And if you take a plus q charge, okay, then how you can apply, how you can find the potential? So you can take another q dash here. So directly you can draw a straight line to this, and the charges, imaginary lines, can be drawn to find the potential here. Okay, to find the potential there, you can apply this form, right? And also like you can draw here a equipotential surface. This is the equipotential surface. Okay, this is equipotential surface. Okay, where v is equal to 0. Okay, here you can take a equipotential surface where the potential is v is equal to 0. Now if you want to find the potential at point P, okay, potential at point P means, for example, if it's here, potential at point P. Now to find the potential at point P, how you can find? There is a potential on point P due to this plus q charge and q dash charge also. Okay, so due to this charge and due to this charge. due to this charge point P and due to this charge. Like due to both charges there is a potential created at point P. Correct? You understood? Like you understood this problem, like how I took that. Okay. Yeah. So like let us move on to the some points regarding this method of images. I will discuss some steps. Okay. Yeah, like this is the method of images concept. Like definition I told, like some points like how you can describe this. Like in next video we will tell some, like I will tell some points regarding the exact steps. Okay, on order by order, exact steps how you can follow this method of images to solve the potential at a point P. Right? Yeah. Subscribe my channel. So like we will do some more problems, like we will do some more examples regarding other topics in CSIR NET, GATE, and also regarding to JEE Advanced Mains. Right? Yeah. Like okay. Thank you.